The fundamental defect in RDS is the deficiency of pulmonary surfactant. Do you know what surfactant? Do you know? Okay. No voice. Do you want to explain? Do you want to explain what is surfactant?
It prevents the collapse of the lung.
Prevents collapse of the lungs. Yes, this is kind of protein which are in the lung, in the alveoli, and it prevents the lungs collapsing. It prevents the collapsing of the lungs. And do you know which cells secret surfactant? Pulmonary alveolar pneumocyte type 2. Pneumocyte type. Okay. So, the defect in RDS is the lack of surfactant in the lungs. On close examination, in microscopic examination of the lungs are solid, airless, and reddish. They're fleshy, similar to color liver, and they usually sink in water. What we can see in the oral slides. Three main pathological features are the main characteristic features in RDS, respiratory distress syndrome. One of the features is emphysema. What is emphysema? Do you know? It means hyper-elevated alveolar. The air is the alveolar space. You know, you have alveolar space. You have some alveolar septa, and in between there are alveolar space. Alveolar space is full of air here in emphysema, and the alveolar septa have some they go far from each other. Okay. So you have the accumulation of air in alveolar space. It means the term is emphysema here. Okay. The other feature is atelectasis. It means the collapse of alveolar. Okay, collapse of alveolar space. And the main feature is presence of eosinophilic hyaline membrane lining the alveoli. In alveolar septa, you see the position of eosinophilic material. Hyaline membranes result from fibrin. So the eosinophilic material in alveolar septa is basically fibrin. Okay, cellular debris and red blood cells. Here it's the histology of RDS. Can you see the mouse? Yes. What are these? What are these here? Do you know? They are alveolar space. Okay. They are alveolar space. And these are, what is this? It's hyaline membrane. But what is the name of histology of here? It's alveolar septa. Okay, you have alveolar septa here, and in between it is alveolar space. Go back to histology. Okay? And in hyaline membrane disease, you see the position of eosinophilic material, which is originated from fibrin and lies RBC and cell debris. You can see the position of this eosinophilic material in alveolar septa. And you can see few cells which are embedded within the hyaline membrane. You call this eosinophilic material hyaline membranes. And here you can see some collapsed alveoli. You cannot distinctly see alveolar space here. The alveolar septa are collapsed here. So you have some alveolar spaces which you can see accumulation of air here, and you have some collapsed alveolar spaces here, and this is edu.m membrane, which is the position of eosinophilic material. It is in high power. In high power, you can see here some collapsed alveolar spaces, and here is the position of eosinophilic material. It's a hyaline membrane. This is also alveolar spaces here, and alveolar septa are thickened somehow, and you can see the position of eosinophilic material, hyaline membrane here. This is the position of eosinophilic material. This is hyaline membrane also here. And in high power, you can see here also hyaline membrane. This is hyaline membrane here. Okay. Do you have any question about RDS? No? So what is three distinct morphological features in hyaline membrane disease or RDS? Name it. What we should see in your slides? One is hyaline membrane. One is hyaline membrane, presence of eosinophilic material in the alveolar septa. 2, emphysema. 3, atelectasia. This is 3 main features in RDS. So, the other slide is about neuroblastoma. Okay. Neuroblastoma is basically a neonatal and childhood disease. 90% of neuroblastoma are diagnosed below 5 years old. Okay. And about 40% of neuroblastoma arises in adrenal medulla. So the main indication for neuroblastoma is adrenal medulla. The remainder occur anywhere like the sympathetic chain. So what are the main indications of neuroblastoma? One is adrenal medulla, and the other is sympathetic chain. For a vertebral region of in abdomen, about 25%, and in mediastinum we have 15% of neuroblastoma. So the prevalence of the patients in neuroblastoma is first in adrenal medulla, and the other second is along the sympathetic chain in the body, more frequent in abdomen and less frequent in mediastinum. Neuroblastoma is usually seen in children under the age of 2. Neuroblastoma range in size from minute nodules to large masses more than 1 kilogram in weight. So it can be very small or it can be very large. Some are sharply demarcated, some of them may be encapsulated, and some of them may be more infiltrated with areas of necrosis, cystic change, and hemorrhage. Okay? So necrosis is one of the features you can see microscopy in neuroblastoma. So we want to speak about microscopy of the neuroblastoma. In neuroblastoma, we have some small, it's a kind of a small blue round cell tumor. It's a pattern in pathology, okay? A small blue round cell or a small round cell tumor. In a small round cell pattern, you have some cells, tumor cells are small in size. They have a small round nuclei with basophilic chromatin pattern. and they are very primitive appearance. Okay, it's the lack of differentiation. They are very primitive in morphology. They have a dark basophilic round nucleus and scant cytoplasm. The cell borders are indistinct, are poorly defined, and you can see solid sheets of tumor cells. It's a range of, you have a range of differentiation. Okay, the lesion may have a range of differentiation. The most differentiated lesion in this category is ganglioneuroma. Okay? Do you know what neuroblast? Neuroblast is the original which cells in our body. Neuroblasts. What? Neuronal cells. Yes, one of them are neuronal cells or ganglion cells. Ganglion cells. Yes, neuroblast can differentiate into neurons or ganglion cells. Okay? So the more differentiated lesion here is ganglioneuroma. Okay? Ganglioneuroma is the most differentiated lesion in this range. And neuroblastoma is the less differentiated. Okay? In between, you have ganglioneuroblastoma. Ganglioneuroblastoma. In ganglioneuroblastoma, some of the neuroblasts has been differentiated to ganglion cells, but some of them are neuroblasts. So it's a range of differentiation in this category of lesion. What we should see. Here we have sheets of small round blue cells, and we have eosinophilic fibrillary material in the background, which is named neuropil. Neuropil is the cytoplasmic extension of some neuroblasts. It makes neuropils. And you can see some pomeroids, rosette. Do you know what's rosette? Do you know what is rosette? In pathology, rosette is one of the histologic features which we can see in some of the tumors. Okay? In rosette formation, you can see the accumulation of tumor cells around a central area. The central area is different in types of rosettes. Here you have pomeroid pseudorosette, which means the central area of rosette is made of neuropils. Okay, you have neuropils here, and the tumor cells are arranged around the neuropils. You can have another types of rosette. Do you can make some other types of rosette? Or some kind of tumor which show rosette formation? You have some, for example, you have a tumor named ependymoma. Ependymoma is a central nervous system tumor which make true rosettes. True rosettes, some of true rosettes, the central region is empty. Okay, there is no neuropil or any cell or any material. You have some pseudorosette or vascular pseudorosette. Sometimes in ependymoma, the central region of the rosette have a vascular structure, the vein in the middle of the rosette. So you have a different kind of rosettes or pseudorosettes. Here, the central region is filled by with what? Neuropils, which is cytoplasmic extension of neuroblasts. Neuropils. Okay, it's the morphology of neuroblastoma. You can see sheets of a small round cell tumor here. And the cells have the very dark basophilic nuclei, and you have some septa here, which have some vascular structures here, and this is the low power examination of neuroblastoma. In high power examination, examination, you can see neuroblasts here, which are small cells with round dark nuclei and scant amount of cytoplasms arranged in the sheath. And this is a pomeroid rosette. In the central region of this rosette, you have neuropils, which are cytoplasmic extensional neuroblasts. And these are tumor cells, neuroblasts here. These are rosette here. Here you can see the arrangement of tumor cells, which are small round cells with dark nuclei here, and the central region of the rosettes are pinkish material here, which is neuropils, the cytoplasmic extension of the tumor cells. The background is fibrillary. Okay, fibrillary. You can see a fibrillary pattern here. You may see areas of calcification in the tumor. This is the position of calcium here, calcification. It may be seen in foci of calcification, you can see. And this is another picture of pomeroid rosette here. And these are also neuroblasts which are embedded in a fibrillary background. Any question about neuroblastoma?
No.
What's the neuropils? You said what are the neuropils?
What is neuropils? Neuropils is the cytoplasmic extension of neuroblast. Okay? In most cases, you have neuropils. Okay? The presence of neuropils is in favor of more differentiation of the neuroblast. In some kinds of undifferentiated neuroblastoma, you cannot see the neuropils, it lacks of neuropils, but in more differentiated, even if poorly differentiated or differentiating type neuroblastoma, you can see neuropils. These are pinkish material and it's composed of